Hey, so cool. How are you doing?
Uh, Hi there. Uh,
Hey,
I'm
oh,
fine, thank you. How are you too?
pretty good. I just got back from the IRPS conference, International Physics Reliability Symposium or something. And so
Uh,
my head is kind of full. I start talking to all these silicon device reliability people all week.
well,
Turns out Charlie, who attends this meeting, was chair of that conference in the past and is well known in that community. So I had the pleasure of spending a lot of time with him, and it's really interesting because Charlie's relatively new to like the RAS and data center reliability issues, but he has this really deep understanding of semiconductor reliability. So he and I started chatting, and I don't know, I feel like I was drinking from a fire hose. It was a lot of fun. Anyway,
nice.
I wanted some of the things we learned convinced me that we're on the right track here. And in fact, there were some device reliability people from Micron
Uh-huh.
there. And really, we need to figure out how to gather all of this data more consistently and more as a normal matter of course in a way that we can share it with silicon designers so silicon designers can figure out where on the chip the problems are occurring. And then so that the device reliability people can look at the devices that are failing and try to figure out, what caused the failure and how to prevent it.
Yeah,
So it was
right.
really cool. I mean, yeah, you all at Micron know that well, but I'm convincing some others that don't know it. Well, um, hey, we decided to cancel the meeting today because it's spring break and a lot of people are out. So I just thought I'd check in and let anyone know that popped on that the meeting was canceled. And I'm afraid, do you not get the emails from Yogesh?
I got the email from Yogesh. I just wasn't sure if there was any update for what we should be focusing on. I was out the past couple of meetings, Drew, as I was out on spring
Okay,
break.
okay. Well, oh yeah, I see. There's okay. There's three of us. Cool. Well, yeah. So we canceled, and yeah, we'll pick it up next week. I think Anil wants to go over some. He had a few topics he wanted to cover, and I think there's some I/O stuff he's been working on. He wants to mention, and then uh, I'll keep writing up some of the scenarios in the doc. I wrote up a memory scenario. People
Mhm.
just don't get memory error logging. I mean, like I can have a fault in memory and see no errors, and then someone writes a value where the failure doesn't match what like sometimes when you write to memory, if it's stuck at one and you write a one, you get no error. And so I wrote a scenario that kind of describes a fault that goes unnoticed, then it goes noticed only by the patrol scrubber. Then the OS starts using it, we notice it, and then they write some more ones, and it becomes a more widespread error. And so I'll keep writing stuff like that up. But I want to try to illustrate uh, some of these common analysis cases. And one of the things we need to figure out, we need to get better alignment on is how RAS features work. Because when we invented the original ECC and well, IBM did it, but then we also we had all these ECC structures that have carried over uh, from like RISC scale up processors down into x86. At HP, when I was working there, we were actively working with Intel to get these features like chip kill ECC into their processors. And the whole intent of those features was that they increased the reliability of the machine enough that we could limp for long enough for a person to come out and repair the machine. That time scale is on the order of a month because you've got to tell the customer they have a problem. We had remote telemetry. You've got to arrange for a time to bring the machine down, and then someone's got to gather together the parts and drive out to the customer site. And so that's why you'll hear me assert pretty fervently that I don't think there are a lot of really fast actions that the analysis tools have to take. And if we can do it things in order minutes, most reliability features will keep the system up. If there's anything that has to happen at real high speed, it's usually like a link width reduction. That's at transaction speed. That has to be done in hardware. So, or like an operating system, something running in an OS reads a poison transaction. That is another transaction level issue that has to be handled in this case by the OS immediately. But the RAS actions we're talking about, post-package repair and driving something like that, we've got time. So if it takes a few minutes to figure that out, in fact, it may take a week or two to find the pattern that says, oh, this is a failed row as opposed to a failed bit. So anyway, that's what I think we need to dig in on some of these things in the future and figure that out.
Yeah, it would be great to review those sections that you've added, and I would be interested in learning more about it as well. So,
Well, there's this mythical medium fast thing that has to happen, and I can't find it. I mean, I've been doing this for decades, and I can either categorize things at transaction speed or a slower time scale, but nothing on the order of firmware has to take an interrupt and keep the system running. If firmware has to get involved to keep the system up and running, and that involvement has to be because we can't do it out in the cloud, something has seriously gone wrong, like in our design. So we'll dig into it, and I'd love to learn something. I hope I'm right, but if I'm not, I need to know. So anyway, do you have other topics you all want to see covered?
I sorry, I for commandeering the conversation, Sakul, but no, my main thing was just I wanted to make sure I didn't miss or maybe learn what I missed from the couple of last meetings we had, but just gonna try to catch up.
Sounds good. Well, if you look at the a lot of it was just reviewing the sections, and I put a new picture in the document.
Mm-hmm.
So Anil had incorporated the in-band stuff, and it was ugly, and not because Anil did that, but because the document had some kind of stale stuff from the out of band. And so what I did is I saw what Anil had added, and I saw the stale out of band stuff, and so I cleaned out the stale out of band stuff, and then I could simplify. And then Anil, or then Vilas at AMD said, "Wait, you should make these all look the same because they all act the same, like with respect to SOCs, logging errors, and like a PCI device." So if you look at the drawing, it's hopefully simpler now. But if you see something wrong, let us know.
All right.
Okay.
Me.
Well, with that, I'll give you your time back. I just, but it was good to talk to you all. Oh, so cool. Do you have anything you want to cover? I can't hear you. You may still be.
Oh, was that to me or was that to Sakul?
Just a cool.
Okay.
Okay. Yeah. So I mean, I thought that you also have a meeting on GPU also. I think just before this call. So I mean, is that on the uh, OCP itself, or do you have a separate call with
It's an
NPD?
OCP. Well, it's an OCP meeting, but it's a closed one right now, and I am not driving that. So I think we are supposed to open it up to be more public, but I think we were working with some new partners where we needed to have some calibrated conversations, I guess, to put it delicately. But I honestly don't know why it's closed at this point. So I don't know. Let me dig into that and I'll see if we can invite more people. But I don't drive that meetings process. I just try to contribute the technical stuff. So let me see what I can do.
Okay. Okay. Thank you.
Yeah, you're welcome. Thank you. That's a good question. Okay. Well,
Okay, then.
well, with that, I guess we'll wrap up. But it's good talking to you all, and if you have a good weekend, and I guess we'll talk next week.
Okay. You too. Thank you.
Yep, me too. Looking forward to get involved in the thick of things again. So
Yeah, me too. I guess spring break just kind of threw us the last couple of weeks, but I look forward to it too.
yeah. All right. Take care. Have a good weekend, guys. Bye bye.
Yeah.
Yeah. Bye.